Hello and welcome back. In this session, we will take a look at some of the built-in data types: numeric, bool, sequence, set, and mappings. So let us start with numeric data type. Numeric data type contains three data types. One is int, the second one is float, and complex. Let us take an example of each of these. Let us go to PyCharm. Here under app.py, whatever I had before, I have deleted that. And we will start looking at the numeric data type. Numeric data type, and first is int. So let us declare three variables: a is equal to 10, b is equal to 12.65, and c is equal to 2 plus 5j. As we already know that we need not have to declare variable data type. Based on the value which is assigned to that particular variable, it decides what type of data that variable is going to hold. So as a is assigned with 10, by default this will be an integer type, and b will be of type float, and c will be of type complex. As we have seen in the last session, we can get the type of data type by using a type method. So we will print type of a. Similarly, we will print type of b and c. Okay, let me save this and execute. The first one is int, second one is float, and third one is complex. If you look at complex, it has got two parts in it. The first part is the real part, and the second part is imaginary part. We have also seen that int is of type immutable. Let us type in the ID, that means the memory location of a. So let us take a as an example here. So what I will do is I will print ID of a, which is going to print okay. And what I will do is a is equal to a plus 15, and then I'm going to print the value of a, as well as I'm going to print the ID of a. Okay, so earlier the value of a was 10, and I'm printing the location, memory location of a, and I'm incrementing the value here. And I'm again printing the value of a and the memory location pointing to a. Okay, so let us execute this. Okay, the first memory location is printed here, which is the memory location of a when a is equal to 10, and the value of a becomes 25 after adding 15. However, if you look at the memory location, the memory location is not the same as it was before. Now the memory location has changed. As per our immutability, an immutable object can't be changed after it is created. Okay, it was created here with value of 10. Once we add additional value of 15, what it does is it creates another object of a. it doesn't increment the value which is present in this memory location. However, it creates another memory location and puts that value of 25 in this memory location. Now this is a, okay, the value initially was 10, okay. Now this is a plus 15. Now the value is 25. Okay, earlier value of a was 10. Let us assume that 1122 is the memory location where the value of 10 is stored and it is represented by variable a. Okay, instead of changing this value from 10 to 25 at 1122, it has created another memory location and the new memory location contains 25. This is nothing but immutability. Another interesting thing with Python is I have declared two variables here, x is equal to 10 and y is equal to 10. Both these variables have got the same value even though the variables are different. So let us print the memory location of these two variables. Print id of x and then print id of y. Okay, so let us execute this. Okay, so let me comment these out so that it is quite clear. Okay, now I'm printing only x and y. If you look at this, even though the variable name is different, okay, since the value which is holding in x and y are same, both of them are pointing to the same location. Rather than creating two objects with a different memory location, both these x and y variables are pointing to the same memory location. So if you look at this in a pictorial representation, so let us assume that this is x and this is y. Now x is declared as 10 and y is also declared as 10. Let us assume since x was created first, so it is at this memory location 3333. Now since y is also having the same value, instead of creating another memory location, what this y will do is it will point to the same memory location as x is pointing to. Okay, so this is how internally Python utilizes memory. So this will not get created. Now if I change the value of y to 11, now if I re-execute this, now you can see those are stored in different location. Let us try one more thing here, 9 plus 1, and execute this. You can see since the total value is 10, it is still pointing to the same location. So whatever I have tried so far with integer, you can try the same with float and complex. If you face any issues, you can always get back to me.